Hi friends, welcome to Civil Architecture tutorial channel. Today's subject is about flat slab. Some of you might have heard about flat slabs, but many of you may not have heard or seen the flat slab because we are familiar with the slab and beam system where we can see a slab first, then a beam downwards, and then it is supported on a column. So that is the usual pattern that we are seeing everywhere. But there is a system called flat slab system in which they are not using any kind of beam there. That means no beam at all. So why they are using is that it will give a very neat surface downside, that means inside. So if there is a beam, it's actually a hindrance to the view and the site, and there is no need of any false ceiling if there is no beam at all. And for the wiring, electrical wiring, conduiting, all these things will be very easy if there is no beam, because there is no intersection, or we don't need to pierce any beam to transfer one conduit to another room through the beam. So it gives a very neat appearance. Also in cost wise too, the slab beam system is more expensive than the flat slab system, and I will do another video comparing the flat slab system and the slab beam system. So now we focus into the flat slab system only where I already said that there is no beam at all. So that is the main speciality of flat slab. So this is, if consider, this is the slab, this is a slab, and usually in the flat slab system we will have, instead of beam, there is a small portion called drop panel above the column. Means there is no beam, that's okay, but we have to provide a drop panel where the column meets the slab. The why it is given is that, as you know, since there is no beam, there's a chance for a lot of shear to happen at the joint where the column meets the slab, and this will lead to the puncturing shear by which the column may rupture into the slab. So in order to avoid that, we are giving a drop panel there like this. This is a section, this is a slab, so there's a small drop panel then, and after that the column will come. Okay, usually the minimum depth of the a flat slab is 125 mm, and here usually I have seen it as 200 mm. We used to give the depth of the slab, and the drop panel could be 150 mm, and then the column will continue. So how the reinforcement in the flat slab that we are laying in the flat slab is like, there will be a top mesh and there will be a bottom mesh. It will be a mesh. It will not be a single line reinforcement. It will be crosswise. That is top. It will be like a mesh. So that, because we are not using any beam there, so the board slab has to take the wall load, the live load, dead load, everything that comes on the slab. The wall load has to be taken by the slab, and it has to be transferred directly to the column without any beam. So it will go to the drop panels then transfers it to the column, then the column transfers it to the foundation or footing, and from there it goes to the soil. So that's the way the load pattern goes. Okay, and like I said, there will be a top mesh and a bottom mesh, and we are providing some extra bars at particular areas where we have to provide that the structural consultant will do it in the drawing after the structural analysis of that slab system. It also depends upon the live load, all kinds of loads, wind load, all types of loads that will be coming into that slab. He will take into consideration, and he will give extra bars at points where it needs to be given, where more load will be applied. So that will be known after the structural analysis work. So there will be extra bars at some points, and top and bottom mesh reinforcement will be there in the flat slab system. And now we will look into the mechanism by which the force will transfer through these reinforcements. Okay, just an overview of that mechanism of load transfer. So this is the slab. Suppose this is a slab, and this is a column, this is a column, this is a column, this is a column, and here you can see the drop panel, the column. After this column there is a sunken part like this, and this is the column drop panel. Okay, drop panel, when we are using the reinforcement, it will be like this. It will be tied to the top bar. Top bar means it will be tied to the if this is a column strip, this reinforcement will be get tied to here. That is the anchorage length will be here, 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 here. Four sides it will be anchored. The drop panel will be anchored, or diamond length will be there, which is connected to the top bars. Otherwise, where there is the connection, there is no connection. So in order to get the connection between the top reinforcements to the drop panel, it will be connected like this. Okay, and then from here the column will go down. So this is the drop panel area, this is the column, and this area you can see this is the column strip. Column strip, it will be a mesh like this. From one column to column there will be column mesh. Here one column to column there will be column mesh, and in between this is called middle strip or central strip. There it will be only one reinforcement like this. So whenever some force happens on this side, which is the main area, this will get transferred to the column strip. That means the column strip we need to do first, and then only this strip, this line, this reinforcement will lay always on the column strip, not down. So if you see somebody do like that, that is this reinforcement will lay at the bottom. That is false, because this force had to be transferred to the column strip, and from the column strip to the drop panel, like that it had to go. So the inverse thing, the opposite, we should not allow. So first the column strip had to be laid like this mesh, then on top of it this line will come. So like I said, the force will act here, it will convey to this area, the force will go from this area to this area, drop panel, from drop panel it will go to the columns. Sometimes in some areas even the drop panel will not do its function correctly, because maybe more shear load will come, more force will come. In such cases, in order to avoid the puncturing shear to happen and the column may break into the slab, we are giving shear beam like this. Here there is a small beam here, it's like a cross, small beam. On the four sides we are providing shear beams. So what is the purpose of the shear beam is that when such shear force is coming on that particular column, there will be tendency for the column to go pierce into the slab, but if we are providing the shear beam, it will take the wall force into it, and it will avoid the shearing force or puncturing shear to happen on that column. So we are providing in such areas, they are providing shear beams too. It is not necessary to provide everywhere, but it depends upon the structural analysis. If it is any necessity, then we have to provide for that also. So like I said, today I told you about the flat slab, and this section I have defined you, and also the mechanism of load transfer in a flat slab. So I hope this video gives you an overall concept about the flat slab system. So please subscribe, share and like my channel. Till then, goodbye. Thank you very much.